So welcome to today's class. I'm happy to have today's class. We would continue from where we stopped before. And yeah, we would progress from where we have stopped before. So let me share my screen so we can just continue from there. This is quite big. Let me reduce it. You can still see the screen clearly, right?
Yes.
But I don't think this is what we were working on. Let me dismiss. Let me stop sharing and check out for what we were working on. Okay, yeah, this is what we were working on. So, yeah. So, this is what we were working on. You can still see the screen clearly, right?
Yes, I can.
Okay, great. So, we have worked on admin, we've worked on storage type, we've worked on allowances. We started working on balances, right? And for balance, we actually implemented the read balance, and we were implementing the receive balance where we got hook. So for this, let's first start by implementing the write balance. Okay, let me disable this. Let me just snooze it instead. Snooze. So pop function write balance. So write balance, and that's env. Let's make this one smaller. Env. And what are they writing to? We need the address of the person. It's an address type, and we need how much, which is the amount we are writing to the person. That one is an I128. So this function basically is a function to actually set the amount we want to write as a balance for someone. So this function is the function that actually sets a person's balance. So how much you have is based on when this function was called. So we use our data key. In our data key here, what we are looking at here is the balance, right? So look for the balance, and we pass in the address here. Yes. And from there, we say env.storage.persistence.set. We're going to set what's our key. We already have our key. And our value will definitely be the amount we are trying to store. So here we have it. So now we want to implement our receive balances. So with this, all we have to do, we did here for this write balance is just to impute any amount that comes from here, literally. Let me see if, yeah, it's still there. Okay, you know what? Let me just bring this here. So, sorry. So, let me see and bring it here. Okay. So we have this. And yes. So this is good. So we have this here, and so with this we can basically use our write balance function. Write balance function, you can use it for our receive balance. Here we've read how much balance the person have, and all we have to do is just to minus the amount or to add it. But since it's receive balance we are working on, we are definitely going to add the amount. So we're going to say balance plus the amount. So that's that. this one would be ENV, and yeah. What's the error we have here? It said it expected ENV, it found borrowed ENV. So let me see, are we using, okay, let me remove this from here. And this one is asking, oh, you know what, let me just add this to every single one of it. So there's this. So now we've been able to create the receive balance function. And the next thing for us to do would be to create the spend balance function. So spend balance, ENV. Hope you don't have any question as I am implementing all of these things.
No, I don't.
Okay. 9,128. So we first get the balance first. After we get the balance, we use the read balance function to get the balance. We clone the address. So we clone the address, dot clone, and then we say if the balance is less than the amount, we should say it should panic. We should say it should panic, that is insufficient amount. Balance. Right? Okay. If not, it should write to the balance. If it's writing to the balance, it is changing the balance. So notice one thing here. You make this one public. It should never ever be public. Let's make it private. Making it private would mean it cannot be accessed from outside of here. So yeah, having this in mind, we've been able to successfully implement our read balance, our write balance, our receive balance, our spend balance. So what are the things we'll be using outside of here? We'll be using our read balance outside of here. We're using our write balance. We won't be using our write balance out of here, but we'll be using our receive balance and spend balance. So does that make sense?
Yes, it does.
Okay, so let's continue. And this time, do you remember the next thing we want to create? Metadata.
Metadata for a token.
Yes. So before we do anything, you remember what we always have to do here? We always have to add this here. So for the metadata, we use Soroban SDK. Inside of it, we have ENV, we have string. The another one we want to do is to use Soroban token SDK. And inside of it, we have metadata. And we want to actually use the token metadata from Soroban token SDK. And then we use the token utils also. Notice that this is the first time we are using the Soroban token SDK because we'll be needing some certain important features from it. So the first thing we want to do is to create a function that should return our decimal. let's create the read decimal function. Read decimal. So we have env and env. We don't need any other thing to read. It should return a U32. The decimal is always U32. So let's say utils is equal to the token utils. We want to create a new one, new, and passing env there. Yes, but this one we need to make it reference. Okay. And then what should it return? Util dot metadata dot get metadata should return the decimal. So with this, it should return the decimal. So let us go deep into the token utils. Inside of the token utils, we have all of this method inside of it. We have the new, the metadata, and the event. So we are looking into the metadata. So if you click on the metadata, inside the metadata, we have the token metadata. And in the token metadata struct, we have the decimal, the name, and the symbol. So what we tried getting now is we called the get metadata method, as you can see here. Get metadata. And so after calling the get metadata method, it returned this token metadata, which is this. And then we looked for the decimal in it. Do you get that?
Yes.
So going back to the metadata, the next one we want to get obviously is the name, right? The token name. So we can get the token name, and all we need is still the same thing because we are literally doing the same thing. Everything is inside that token data metadata struct, right? So we're going to return it. It's just logical that we are using the Soroban token SDK just for this metadata. You know why? This is because one of the most important things that the scan will use to recognize a contract as a token contract is this fundamental. The token name, token symbol, and the decimal. So if it can see that, okay, this trait was implemented, then it identifies it. So you don't just create that metadata by yourself. Instead, you just use the token metadata from the token utils just to do that. You get that?
Yeah.
So we have util. Let's util equals token utils. We have our env and just the same thing. Util dot metadata dot get metadata dot. This time, what would it be?
Token name.
Good.
Right?
Yes, so that will be dot name. So the next thing, why are we having this error? Can you tell me?
Can you like put your cursor? Let me see. Can you like put your cursor? Let me see.
Without putting my console, can you just see it and just tell me?
Is it like the like what's it called? The isn't it called comma? Oh, that's so.
Which stuff?
No, you have to return. No, you're already returning it now. You need to return U32. Abby?
That's
But
the
right now,
point.
returning the
We are the token name is a string, but I am returning a U32. Can you see the problem? Assuming I have this as string, then the error is gone.
yeah.
The next thing we want to do is to check for the token symbol. Notice that in the other implementation, what were we using for, what data type were we using for the token name and symbol? Can you remember?
No, really, I can't remember.
We were using symbol macro.
Oh yeah, symbol macro, short string.
Yeah. So
But why?
that's because we did not want to go through the hard way. We wanted to do wuru to the answer. But now we are going through the hard way and the right way. So that token symbol has a maximum length it can take. You get?
Yeah.
So, but a string does not have like a definite maximum length it can take, like the symbol macro in Soroban. So this would then be what?
Dot symbol.
Excellent. So do you have idea of what function we'll be writing next? Hmm?
Not really. What do you want decimal name symbol? I don't want anything.
Think.
I don't normally. I was trying to put me in the box. Wait, is it next one? Why are we using symbol for using? Okay, wait. Normal token symbol though. Okay, symbol name decimal. And check. Sweet, it's so good. Supply. I don't know if I want. I was supposed to supply.
No, we have implemented the read. Are we not meant to implement write? What would these token symbols return if you don't write it there? Notice the balance. We implemented the read balance. Obviously, we would implement the write balance. So it's more like we are implementing the set and get. You get? This is the get.
Yeah.
All of these are get functions. They are getter functions, right? They are returning it. So what do you expect us to do now?
Function to write. Rule to write.
The setter function, which is write metadata. To write the metadata, if we go back to this metadata and we click on it, we go there. Okay, click on this. Now look at this metadata. It has what and what? Get metadata. Can you see it?
Yes.
And what? And set metadata. Good. So we divided this function into three by destructuring this into three different functions. You get that?
Yeah.
So this one, we need to create a function to set it all. Is Coxie still with me?
Yes, I am. Can you hear me?
Yeah, I can hear you. So this one, it will be write metadata. So we have EMB, right? And then we can do it in two ways. We can either write the metadata directly, because obviously we are not using, we are going to use this function somewhere else. Or, can you give me a second, please?
Okay.
Yeah. Okay, I'm back. So let's just continue.
Okay.
So what's the next thing we are meant to do to create the right metadata? So now for this right metadata, like I said, token metadata, what we want
Set.
to do, eh?
I'm guessing you set it using the
Yeah,
dot set function.
we can, that, like I said, remember that this token metadata is all of this. We can choose to pass
Yeah.
everything once, or like, let me
Okay.
just implement it.
Or why don't
We
we
can,
call, or can we call the get set function to set function instead? Since that function is already calling it a reference to the document data structure.
I didn't get what you said.
I said, or can we like call the set metadata function instead, since that function is already calling the document data structure?
You mean set incremental function?
No, set metadata function, like the one that is up,
Yes,
like
that's what we are
where
going
you
to call. That's what we are going to
okay.
call dot set metadata. And then here's the metadata we want to set. So we will create a reference to it and we set it. This is it, right? This is one way to do it.
Yeah.
Another way to do it would have been, let me just copy all of this. And I will just do this. Let me comment this out and let's see another way to do it. Another way to do it would have been to have like your name as a string, the symbol as a string, and then what's the last one? Decimal as a U32, right? And then inside of this place, we could just do reference token metadata name decimal and symbol. and this would have also been perfect. So which one do you prefer between this one and this one?
I think the first one better.
The first one, right?
Yeah, it's simple.
I'll take this, or we'll just use the first one. Okay, with this, we now have our metadata completed. Our metadata that includes the decimal, the decimal, the name, the symbol, and also to write and create all of this. So we can say we are officially done with all of the creates we will be needing to write our function. Do you get that?
Wow.
We can say we are done with
Yeah.
all creates we'll be using or needing to write our function. So the contract itself, we will now write it as contracts.rs. So, as usual, in this mode, we have contracts here. So now we want to use all the crates we have ever created. Create for the admin. What are the things inside of the admin? Bam, 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 bam. You want to use is administrator, return admin, and add admin. You know what? Since we have been using write and read, let's just change all of this to the normal syntax that we have been using. Let's change this one to read admin, and let's change this to write admin. Okay. So for the admin, we will be importing everything as admin. We'll be using as admin. We'll be using read admin. We'll be using write admin. So that's for the admin. What of allowance? What are the things we are using from allowance? Okay. For create allowance, we'll be using, okay, have I added it? The allowance. For the allowance, what are the things we'll be needing for the allowance? We'll be using read allowance, right? We'll also be using write allowance. What else? Spend allowance, right?
Yeah.
So I think that's all we have here, right?
Yeah.
Good. So what's the next thing we'll be going to now? Balances, right? Let's open balances. So for balances, the create. What are the things inside of balances? We have read balance. We have write balance. You see, we didn't make write balance public, right? So we can't even use it here.
Yeah.
So we have receive balance and we have spend balance.
But that's like an internal function.
Yeah. So what else do we need? Metadata. So what's in our metadata? Create for the metadata. We have our read decimal. We have the read in, read symbol. And lastly, we have write metadata. So we also need some other things from storage, Abby. So
Yeah.
from storage types, we need let's just bring in everything. We need the allowance data key. We need the allowance value. Then we need the data key itself now. Have you?
Yes.
I think we've imported all the crates we created, right?
But why is one showing without showing blue from importation? Like its storage types is showing now. Importation is showing blue, but the
It's
other one
simple
is
now.
showing
All of these ones are methods, they are functions. But these ones are data types. Can you see? They are contract types. They are also, this one is a struct, this one is an enum, this one is a struct. All the others are functions.
okay.
Does that make sense?
Yeah.
Okay. So another thing we want to use again is the Soroban SDK. And in it, we'll be taking account of the token. And in the token, we'll be using self. We'll also be using the interface. Interface still available. Let me see. Token interface. Let me remove this. Okay, let's see. Okay. Then we would also be using some other things from the Soroban SDK. Soroban SDK. Instead of it, we'll be using contracts. Obviously, we use contract implements. That's to implement our struct that is acting as a contract. We also need to import address. We need env. We need string imported. So what else do we need? Have we imported our metadata?
No, we haven't.
We've imported it. Yeah, it is now. The metadata.
Oh yeah.
So, but inside of this metadata, we used something else. We used this metadata from the SDK, right? So let's just import that metadata to that we use. And instead of it, we also imported the utils now. Abi? Wow. So much. So, what's the first thing we want to do? Let's create a require statement. Or let me hear, what do you think is the first thing to do?
Well, since we're getting in contract, probably get the contract structs, they implement the contract.
That's the correct answer. That's the correct answer. But when I made mention of let's create a require statement, I was just referring to solidity in the sense that let's create a function that checked for values equal or less than 0. Or in fact, values less than 0. So we can just call it non-negative amounts. So let's create that function. Check non-negative amount. So the only thing the function does is just panics if there's a problem. It panics if you notice that the amount is less than 0, and it returns this negative amount is not allowed. And then we can even put the amounts that it shouted is not allowed. How are you enjoying Rust so far?
Amazing.
Good. So let's continue. Let's create a procedural macro now. And that's exactly what you made mention of token struct, right?
Yeah.
We created so much. Imagine you were doing this thing in Solidity. How long would it have taken you to write all of these functions?
A whole lot of time.
Huh?
A whole lot of time now because you have to write everything one by one and take a lot of time.
Okay. Okay. So we're going to implement our token, right?
Yeah.
So what are the things that will be inside of the implementation for our token?
Mm. Like this, no. Okay, this one is a bit very tricky. This is a bit
Why?
tricky though
Why is it
because
tricky?
when you have everything, when you have everything at the top, unless you want to like start implementing the um. Okay, this is tricky. Normal, just to be like normal thing like on like you have 20 token. I'm thinking of everything and you have 20 token, but I think it's wrong.
You think is what?
Like what I'm thinking is more of like in the you have 20 token kind of implementation, but I think it's wrong. Normally, just for it to just inherit it, inherit everything you have there, and um, me talking to yourself.
If we wanted to inherit it, it would have been easy. We wouldn't need to bring in all of these functions now. We would have just inherited and brought in just the traits. And if you were talking of inheriting, notice that what we normally inherit is a contract. And the contract is more like inside of an object-oriented programming, in that everything is inside of something that looks like an object. You understand? So that's why when you are writing your Solidity code, you say contract and the name of the contract, then you open a curly braces and you write all your functions inside of that curly braces. Now, what we have done here, if you wanted to do the same thing as what you are saying, it will have been to implement a particular trait that implement all of our methods. But all we only did here is just to create functions upon functions upon functions that are reusable that we would use later on. So think other.
Is it like creating the mint function?
Really? You think that's the next thing to do?
Okay, wait. Like create like maybe we have to like in the token like create a token. No, God, I don't even know. I guess I don't really know what exactly to think. I'm a bit confused though.
You don't know what's happening.
And I don't know what to do next. I mean to say, maybe I will initialize it, maybe initialize the token, or yeah, I'm thinking initializing the token. Initializing the token. What I'm thinking.
What we are going to do is we are going to create all the functions we need. And one of the first functions we need is the initialize function. So we're going to create an initialize function. Initialize. Wait, did Cox did Mubarak and Levi not come because I said we will have everyone do their own distance?
No, I think maybe it's because of the time. Maybe they didn't know that it's class today.
You are supporting your classmates.
No, you know that they have been changing it like So it was class. Even I had to set my reminder today. I would have known that it's a class today.
But there has always been class on Tuesdays.
Oh, that's true.
The only days changed was Thursdays to Wednesdays.
Yeah.
Yes.
It was Monday and Thursdays.
No. Wednesdays and Thursdays is the only days changed. Well, Thursday class have been brought forward to Wednesday. So
That's true.
for the initialize function, we have our env, our admin, our decimal, the name of the token, the symbol. All of these things are the things we want to initialize whenever we deploy the contract finish. It's more like we want to call it like a constructor.
Oh.
So we are going to see it as a constructor. You get. So
like automatically initialize function is like creating a new token.
What do you say?
Is it that this initialize function is like creating a new token?
No. Whenever the initialize function is called, when you deploy the contract, the first function we want to call is the initialize function. It's just like when you deploy your contract, the constructor is automatically called. The constructor is also a function in Solidity. But it is called during deployment. You understand? So it is initialized. Everything you do inside the function is initialized. And that's the same case as what we want to do here. Now, the first thing we want to do is we want to set an admin for this token. So we are going to write an admin for this token, but we are also going to check if an admin has been written for this token. You understand?
Yeah, admin it sounds like this ownership thing in Solidity, like right?
Correct. So first of all, we want to check if as admin, we want to pass the env as a reference. What should it do? It should panic. What's the noise you should shout? Hello?
I can hear you.
Initialize. I wasn't saying you. I was saying what should it shout as an admin? I'm saying the reply should be hello, I have been initialized. Did you get that? Now, but if it has not been initialized, we want to call the write admin function. And what the write admin function will do is it will pass in an admin and it's going to set the admin here, just like you can see.
Okay.
So as admin, I think we should just add this here. So let me just.
She's using the admin address to check that admin. The admin address to check.
So why is this one? It's saying can't find admin address. Okay. Within this should be.
And I'm guessing that it's it's more of like a required. So I'm guessing that if it's more of like a required statement in here.
Yes, that's what I'm saying. It's a required statement. In Solidity, whenever you are using custom errors, you are always using if, right? So it's still the same thing, literally. Yes. That's why, remember from yesterday's class, I was telling you that if you understand the fundamentals of writing a smart contract, the language is not going to be the barrier for you. Understanding, okay, how do you create your permissions? When I say permissions, you already know if statements, require statements, you already know all of these kind of things. Then how do you set to your storage? How do you get from your storage? How do you initialize? How do you create a function? So once you have the idea that these are the things required in a Solidity, in a smart contract, I mean, no matter the smart contract, whether Soroban, Ink, Solidity, even Concordion, any smart contract, you'll be able to do it, just like I've made mention of. You get. Does that make sense? Good. So
It does.
the next thing we want to do is we've written to admin if it doesn't have admin. So writing to admin, creating an admin of the token is literally what we are using to initialize the token, to set that the token has been initialized the moment we check that, oh, it has an admin. Next thing we want to do is to check for the decimal. We want to see that if the decimal is greater than 18, we want to tell the person that, hello,
Yeah.
decimal.
This hello is talking to me.
Okay, we can see. In fact, let me type it out. Hello, decimal cannot be greater than 18. Cannot be greater than 18.
But I thought you said that. Okay, wait. Oh, I thought you made mention the fact that Sobam contracts like 6 decimal.
No, that you have misquoted me. I said that tokens in general have different decimals. So that we have some tokens that have 6 decimals. We have some that have 9 decimals. We also have some that have 18 decimals. But most of the tokens are usually having 18 decimals. But cannot exactly decimal of the token unless you check. That's why we are putting an opportunity, like a gauge to it, that, okay, the maximum a person can set for a decimal is 18. So according to this setting we just written in our code, can this person set 17 as his decimal?
Yeah.
Exactly. The code rules. So what's the next thing we want to do? We want to write to our metadata. So remember when I said write to our metadata. Now, remember our metadata now is not just this thing. Now, it takes in env. Where is metadata? Here it is. Write to metadata. It takes in the env and the metadata. And the metadata is taking in the token metadata. So here we have to create a struct, token metadata. And inside of it, we have to pass in. Do you remember what we have to pass in? Name,
Symbol.
decimal,
Symbol.
and that is basically it. With this, I am happy to announce that we have completed our initialize function. And in fact, this is where we'll be ending our class for today. Tomorrow, Wednesday, we will continue from where we stop, and by God's grace, tomorrow we are going to complete our implementation for this contract. So until then, thank you so much for attending the class, even with the odds. I really appreciate your dedication to the class. So I'll stop the recording and